Hello guys, let's actually look at this correction and how you should have done it. If you're still struggling throughout the questions, well, I apologize for that. Okay, let's see. They want you to differentiate, from first principle the following. So remember, when you differentiate or when you find f prime of x, it means gradient. So just normalize that because you're going to use it a lot in the near future. So if you find f prime of x, it means gradient. F at x means the y-intercept, and then f prime of x means the gradient. Yeah, let's actually look at it. How can you differentiate f at x minus 4x squared using first principle? So you know that you're going to use the formula f prime of x equals to the limit as h approaches 0. Well, I'm going to have f, x plus h minus f at x divided by h. So I want to find the limit f prime of x as the limit h approaches 0. So let's look at it. I'm having minus 4. So where there's x, I'm going to substitute x plus h, and then I square them. I minus, what if f at x? F at x is minus 4x squared. I'm going to have minus 4x squared, and then I'm going to divide this entire thing by h. So the limit as h approaches 0, I need to expand this. So if you expand this, you're going to find it is going to be x squared plus 2xh plus h squared. Now this is just going to give you positive 4x squared, and then you're going to divide this one by h, right? And then you're going to times the entire thing with minus 4. So the limit as h approaches 0, it becomes 4 minus squared minus 8xh minus 4h squared plus 4x squared, and then you're going to divide the entire thing by h. And you realize we're having minus 4x squared, and this one is a positive 4x squared. They're actually going to cancel out, and you are forced to be left with minus 8xh minus 4h squared divided by h, right? So what's actually happening? You realize you want to take the common factor of h, so you can actually cancel it out with the h on the bottom. So you'll be left with minus h. In fact, let's just take the positive h. You are having the limit as h approaches 0. You want to take the common factor of h. You are left with minus 8x minus 4h, and then you divide it by h. So the h and the h will actually cancel out. So you are saying that, well, the limit is actually approaching 0. So it means you're going to say, well, minus 8x minus 4, and then you want to substitute 0 inside, and then you'll be left with minus 8x. So this is how you should have done it. Now let's look at the next question. The next questions say you need to differentiate f at x if it is given by x squared plus x. So you're going to say, well, okay, f at x, or f prime of x, the limit as h approaches 0, we need to find f x plus h minus f at x equals to h. There's a mistake that one of you have done when it comes to this stage, and I want to show you something. Let's look at this extremely closely. We are having the limit as h approaches 0, right? Wherever there is x, we are going to put x plus h. So let's look at this. We are having x plus h and then the squared. Remember, there's also this x. So you're going to say plus x plus h. Do you understand it? And then you're going to minus it with f at x, that is just x squared plus x. And then you're going to divide this whole thing by h. So you're going to have the limit as h approaches 0. Remember, when you expand this, you're just going to get x squared plus 2xh plus h squared plus x plus h minus x squared minus x. And then you're going to divide this whole thing by the value of h. Now the limit as h approaches 0, you realize that the x squared and the x, the x squared and the x squared, they're actually going to cancel out, and then you are left, oh, look at the x and the minus x, they are also going to cancel out, and now you are left with 2xh plus h squared plus h, and then you're just going to divide this by h, right? So you want to take the common factor of h. This is a common step. And most of the time you want to take out the common factor of h. If you take out the common factor of h, you are left with 2x plus h plus 1 divided by h. So the h and the h will cancel out. Now the limit approaches 0. Whenever there is h, you're going to substitute 0. We're left with 2x plus h is 0 plus 1. So your answer is actually 2x plus 1. You see, so the trick was you need to put x plus h whenever there is x. Now let's also look at this other question. My WhatsApp is ringing like crazy. Okay, let's also look at this one. You want to find the limit as h approaches 0 for f(x) plus h minus f at x divided by h. Now let's actually look at this. So the limit as h approaches 0, wherever there is x, you're going to put x plus h. So you're having 2. Whenever there's x, you put x plus h, and then you square it, minus 3. Wherever there's x, you put x plus h, and then you minus it with 2x squared minus 3x, and then you're going to divide this entire thing by the value of h. Now the limit as h approaches 0 is going to be 2. This is going to be x squared plus 2xh plus h squared minus, you times this out, you're going to have minus 3x minus 3h minus 2x squared plus 3x, right? So you're going to divide this thing out by the value of h. Now the limit as h approaches 0, it is going to be, you times this out by 2x squared plus 4xh plus 2h squared, and then you'll be left with minus 3x minus 3h minus 2x squared plus 3x, and then you're going to divide this entire thing by the value of h. Now the the 2x squared is also going to cancel out with minus 2x squared. Let's look at this one. 3x, and the minus 3x is going to cancel out with the 3x, so you are left with 4xh plus 2h squared minus 3h divided by the value of h. You want to take out the common factor of h, so the limit as h approaches 0, so you want to take the common factor. Okay, so you want to take the common factor of h. You're going to have 4x plus 2h minus 3 actually equals 2h divided by h. So h and h is actually going to cancel out. You're actually left with 4x minus 3. If you know that the next step, you're just going to substitute 0 wherever there's actually the value of h. So you find that f prime of x is just going to be 4x minus 3. By the way, on the next step of calculating this using rules, you're gonna understand that you actually, just by looking at this, you immediately know the answer. Just by looking, you immediately know the answer. I'm gonna show you how you do it just before the end of this video. Okay, there's actually an end, guys. Okay, so okay, which one do I think we haven't done? Okay, I'm not going to do this one because it is similar to the first one, right? So let's just do one of this, and then I won't do this one because it's similar to this. And then let's actually say, okay, f prime of x, the limit as h actually approaches 0, is going to be fx plus h minus f at x divided by h. And by the way, I know sometimes I'm too fast. That's because this stuff are extremely simple. You're gonna see the more you practice, the more you become better at it. The more you practice, the more you become better at it. It's extremely simple. Now let's actually put, whenever there's x, we're going to put what? X plus h squared, and there's actually minus 1. Here's the tricky one. Can you see this? It is 2x plus h squared. After that, there's minus 1, and then you need to say minus, and then 2x squared minus 1, and then you put an h into it. So the limit as h approaches 0, this is going to be I've expanded this like a million times, so you know it's going to be 2x squared plus 4xh plus h is 2h squared minus 1 minus 2x squared plus 1 is just going to be h, right? So this is going to be the limit as h approaches 0. 2x squared and this one is going to cancel out. 1 and 1, they're actually going to cancel out, and you're left with 4xh plus 2h squared divided by h. And then you take the common factor of h out, you are left with h that equals to 4x minus 2h divided by h. So this h and this h will actually cancel out, and you realize that you're just going to substitute the value of 0 here, and your f prime of x is actually going to be 4x. Now I want to show you something. How do you find these answers? Let's start with number 1. How do I mean when I say you know the answer before you even write it? So the next step of calculus, it is identifying or is to find f prime of x using the rules. What we have been doing here is to find f prime of x using, what are we using? We are using first principle. What if they want you to find this using the rules? Let me show you something. If you need to find f prime of x using the rule, this is what you do. And by the way, I've sent you videos by now. Here it is. You're just going to say, well, f prime of x is going to be, just say 2. Do you see this 2? Just say 2 times 4. It's going to give you minus 8. And then on this 2, just minus 1. So it's going to be 2 minus 1. That's the same as x. So you see, so f prime of x is just minus 8x, as we have found here. It's minus 8x. If you look at this one, you want to find f prime of x. What do? You're just going to say 2 times 1. It's going to be 2. And then on this 2, you minus 1. It is going to be 2x. This is the same as to the power 1. You're going to say 1 times 1. It is just going to be 1. And you just minus 1. It becomes x to the power 0. And anything raised to the power 0 is just 1. So this becomes 2x plus 1. And let's see what we have found when calculating. Okay, yes, the papers. We have actually found it to be 2x plus 1, right? So this is the long one is identifying using the using the first principle, but there's the one called using the principle, right? Using the rules. It is the short ones. So before you answer this question, just first try to see what is the answer that you're going to get, and then you're gonna differentiate.